Today, we're diving into the essential topic of web security fundamentals, crucial for anyone involved in web development. Our focus will be on understanding how to protect our applications, safeguard user data, and secure valuable business assets online. Let's begin by exploring three of the most significant web vulnerabilities that commonly threaten applications today. These are common exploits that attackers target by leveraging weaknesses frequently found in many web applications. First, we have cross-site scripting, often abbreviated as XSS, a very prevalent web vulnerability. This attack involves injecting malicious scripts directly into web pages, which are then executed by unsuspecting users' browsers. Such injections can lead to serious consequences, like session hijacking or the unauthorized theft of sensitive user data. Next, we'll look at cross-site request forgery, or CSRF, another critical vulnerability to understand. CSRF attacks trick users into performing unintended actions on a web application they are already authenticated with. This exploit leverages the trust a website has in an authenticated user's browser session, making it quite insidious. Finally, we have SQL injection, or SQLI, which directly targets a web application's database interactions. SQL injection allows attackers to manipulate database queries, often leading to severe data breaches. This can result in unauthorized access, modification, or even deletion of sensitive information stored in your database. Now, let's delve deeper into XSS attacks, examining their potential impact and effective prevention strategies. It's vital to fully grasp the risks involved and to implement robust safeguards to protect your applications. Regarding the impact of XSS attacks, session hijacking is a major concern for user accounts. Attackers can steal session cookies, allowing them to gain unauthorized access to a user's account without credentials. Another severe impact is data theft, where sensitive information like login credentials or payment details can be compromised. XSS can also lead to website defacement, where malicious scripts alter the appearance or inject unwanted content onto your pages. Furthermore, XSS can be used for malware distribution, redirecting users to malicious sites or installing unwanted software. To mitigate XSS risks, several strategies are crucial, starting with proper input validation and encoding. You must sanitize all user input and encode output data thoroughly to prevent any malicious script execution. Implementing a strong content security policy, or CSP, helps restrict allowed script sources, effectively blocking malicious injections. Using HTTPONLY and secure flags for cookies is also essential to protect session cookies from client-side script access. Finally, utilizing secure web frameworks with built-in output encoding and XSS protection features is highly recommended. Let's now focus on preventing SQL injection, a critical step in securing your database interactions. We will explore how using prepared statements provides a robust and secure method for database interactions. First, let's understand the problem statement that leads to SQL injection vulnerabilities in many applications. Directly embedding user input into SQL queries allows attackers to inject malicious SQL code, leading to unauthorized database access, making this query vulnerable. Here, we see a code snippet where the email variable, directly from user input, is embedded into the query string, creating a classic SQL injection vulnerability. Now, let's look at the solution. Using prepared statements to secure our database operations. Prepared statements separate SQL logic from user input by using placeholders, like :email, ensuring input is treated as data, not code. Then the execute method safely runs the query. This code snippet demonstrates a prepared statement where the SQL query is defined with a placeholder, and the user email is bound as a parameter, effectively preventing SQL injection. Let's delve into the foundational secure coding principles that are crucial for developing robust web applications. These principles are essential for building web applications that are not only robust, but also highly resilient against attacks. Our first principle is input validation, a critical step to ensure data integrity and security. You must always ensure that all user input strictly conforms to the expected formats and data types. Next, we have input sanitization, which works hand in hand with validation to prevent vulnerabilities. This involves removing any potentially harmful characters from user input to effectively prevent code injection attacks. The principle of least privilege dictates a crucial approach to access control within your system. Always grant only the absolute minimum necessary permissions for both users and system processes to function. Effective error handling is another vital principle for maintaining application security and user experience. It's important to handle errors gracefully, ensuring you never expose sensitive system details to your users. Lastly, let's discuss secure credentials, a fundamental aspect of protecting your application's sensitive access information. You must always avoid hard-coding sensitive information, such as database credentials, directly within your application's code. Now, let's explore how HTTPS establishes a secure connection, a fundamental process for web communication. We'll break down the SSL or TLS handshake into its sequential stages, understanding each step clearly. The process begins with the client hello, where the client initiates the connection and sends its supported SSL/TLS versions and cipher suites. The server hello follows, where the server responds with its chosen SSL/TLS version, cipher suite, and its SSL certificate. Next, during the server key exchange, the server securely sends its public key to the client for encryption. In the client key exchange, the client generates a session key, encrypts it with the server's public key, and then sends it. With change cipher spec, both the client and server switch to symmetric encryption, now using the agreed-upon session key. Finally, encrypted communication begins, where data is securely exchanged using the established symmetric session key. Let's look at some key content security policy, or CSP, directives that are crucial for enhancing web security. These directives help control content sources, which is vital for mitigating various web-based attacks effectively. First, we have ScriptSRC, a directive specifically designed to manage JA-VIA script sources. It explicitly specifies all valid and trusted sources from which JA-VIA script files can be loaded. Similarly, StyleSRC is another important directive, focusing on your application's styling. This directive defines all the valid sources from which CSS stylesheets are permitted to be loaded. The ImgSRC directive plays a role in controlling where images can be sourced from on your page. It specifies all the valid and trusted sources from which images can be loaded into your application. For network connections, we use ConnectSRC, which manages data fetching. This directive defines the valid sources for a JAX requests and WEBSOCKET connections, enhancing data security. Finally, ObjectSRC is used for managing embedded content within your web application. It specifies all the valid sources for embedded objects, such as Flash or other plugin-based content. Let's explore the different types of web security audits that are essential for identifying vulnerabilities in applications. One type is static analysis, often abbreviated as SAST, which examines code without executing it. Then we have dynamic analysis, or DAST, which tests the application while it is running, simulating attacks. Interactive analysis, or IAST, combines aspects of both static and dynamic testing for comprehensive coverage. Finally, penetration testing involves ethical hackers simulating real-world attacks to find exploitable vulnerabilities. All right, let's wrap up our discussion on web security with a concise summary of the key points we've covered. Here are the most important takeaways and practical insights for building and maintaining robust web security. Remember, web security safeguards your applications and data from common threats such as XSS, CSRF, and SQL injection. Implementing secure coding practices, like input validation, Least privilege and proper error handling is absolutely crucial. Always use HTTPS with SSL/TLS certificates to encrypt data during transit, ensuring both integrity and server authentication. Content security policies, or CSPS, are vital for mitigating injection attacks by strictly controlling resource loading. Regular security audits like SAST, DAST, IAST, and penetration testing are essential to proactively find and fix vulnerabilities. Finally, continuous updates and ongoing developer education are absolutely vital for maintaining a strong security posture.